Okay, so we want to look at the word irregular. So irregular. Hopefully we're getting familiar with these lovely things called prefixes. Ir means not, so it's literally not regular. When it comes to a polygon, a regular polygon means that all of the sides are exactly identical, they are congruent, they are equal. These are the cute little shapes that you see when you're in kindergarten. And you look at little triangles and you're like, this is a triangle, and they're always like an equilateral triangle, right? Oh, that's perfect. And then every time you see a rectangle, it always looks like this. It's just a little long, and it's always this direction, right? And everything is just so pretty and perfect. And a rectangle, obviously, that's something they can teach. The regular quadrilateral, something that is 4 sides, and it's regular, meaning it's equal all the way around, would have to be a square. Does that make sense? So this is a regular 3-sided. This is a regular 4-sided or quadrilateral. You have 5 sides. You get the perfect little picture of a pentagon. Oh, I'm sure that's perfect. And so all of those are exactly the same. You know, your stop sign, that is an octagon, that is exactly the same. Instead of like 1, 2, 3, 4, 5, 6, 7. Let's see here. We'll do this. 7, 8. That's also an octagon. Okay? That's just not a regular octagon because you have 8 sides. It can be any direction you want, but it's not perfect. Even if these sides were all somehow, which I don't think is mathematically possible, somehow exactly the same length, the angles would not be. So you have the exact same congruent lines, edges, sides, right? Line segments. Measure the exact same, and then that forces all the angles to be exactly the same. So regular polygons are going to be these beautiful little shapes like this. Look how cute these are. They're just so perfect. See all these perfect little pictures here? Okay. Those are all regular polygons. Whoa. I'm drawn with an octagon. A regular polygon. Polygon means many. Poly means many. Gon means angles, many angles. So regular polygon, I don't know why they just don't call it like equilateral polygon. It was just some regular guy with a regular life and a regular name. And I regularly tell you to marker drop. Okay. So regular polygons versus irregular polygons could mean, again, like if this was a pentagon. Is that 5 sides? No. That's a pentagon too. What's regular about it? This one, irregular right there. Understand the difference? Okay. Now, we do not have formulas for irregular polygons. Okay, those flat plane surfaces. We have formulas for squares and rectangles and normal parallelograms and triangles so far, yes? Okay. You're going to look at these shapes and you're going to see what you can create, how you can decompose them or compose them temporarily and then decompose the extras later into the shapes that you do have formulas for. Sound good? Okay. So for instance, if I was looking at this little like house type shape, I would decompose it here into a rectangle and a triangle. Get the area of each piece and then just add the 2 puzzle pieces back together to get the whole thing. Sound good? Any questions? Okay. Right, God's like, I get it. I have lots of questions. Wait, what? I think you just said, I said, do you have any questions? You're like, I do. I said, what? Oh. You know who that is? That was you. The year that was tell the teacher what to do. Yeah. Lucas likes to stay on task. Yep. Why won't you go away? There we go. Sorry. Ready? Cool. Sketch something like that. I would start with a straight line at the bottom. It looks like lots of things. We don't need to worry about it. We're just going to sketch it. And then I would start with a dotted line as a couple of lines up, and then make that your dotted straight line, and then use the ruler from there to connect inside. Okay? You did it so beautifully. Awesome. Let's see. But you copied it right from there. It's so perfect. I love it. Perfecter. I love that too. Fish. Okay, so I would say there's the dotted line. I would go down a little ways, and then I would do my straight line and be like, that's 20, and this is the 16, and go from there, and then I would, is it straight in? Yes, it has to be. So then you can even go straight down for your 12, and then on to the side for 20. And that is, oh, that just is 12. And then this side, 36. Yeah. And it went like that and that. Oh, beautiful. Okay, we're going to look at this shape and we're going to figure out how do we do this with the information they've given us, the measurements they've given us. How do we make it into shapes that we very easily get an accurate measurement for and have a formula for? Question. Cool. You guys start coming prepared and find a friend.
I found a friend.
Okay.
Yeah, he's trying for very long. You
That
let
is
me take
so
I know, I
sad.
let you. So does anyone have a pencil on here? I have a good time this. Yeah, you know how I do.
Consequences. Okay. So again, I would love to offer you pencils, but people keep shopping at, Christensen's place. This is the name of my store is apparently. Also, shopping is apparently for free here. I haven't been paid anything. Oh, it's called shoplifting. Oh, silly me. Wrong vocab word. Yes, shoplifting. So we don't like to give out free stuff anymore. Because I'm a poor, sadly, it only makes whatever. I'd be long gone, man. No. $1 an hour. That's terrible. Go flip some fries and say hello to people at Walmart for more than that.
Pretty close.
So anyways, we have these lovely measurements. My gut feeling on this one is that I should go straight down. That's totally straight. Because I can see a rectangle here. Do you guys see it? And I can get the area of the rectangle because I have 16 by 36. Yes? We do. So let's see if it's going to be worth it. We're going to take out those little white things. I like that. The little white things called area. Yes. If I were to look at this, let's see here how I could figure this out. I would need, this triangle right here, I could take out because it's 16 by, I need this measurement here, right? So if that is 16 centimeters and this whole thing is 12 centimeters, that looks really legit.
Yeah.
Just a second.
Yeah.
That looks really weird to me.
Yeah, math, right?
Oh, God.
Why is there so many measurements?
Because they're giving you different lines. Let's see here. 16 centimeters. Okay.
Very, very short.
Oh. That's why. It's because I've colored over it. It is smaller. That's 12. Okay. Let me uncolor it here. That's why. I'll mess myself up. So from here to here is 12, but from here to here is 16, which is larger. Okay, because if I were to get this and move it, it should be shorter. Yeah, see how it's shorter? It just ends in right here at the box. So yeah, that's fine. I was thinking this whole measurement up here because I had drawn over it, but that's not it. Okay, let's talk about all the measurements first of all and see what measurement goes with what. Sure, it's gonna bug me. Okay, so 20 is from here to here. Okay, everybody sees that? Okay. 36 is the height from there to there. Is it the measurement of that diagonal line?
No.
It is not. Otherwise, the 36 would be right against this line. Does this make sense? Okay, so 36 is against this line, so that's the height. 16 is from here to here, not this measurement. Otherwise, the 16 would be up against that one, okay? This measurement, 12 centimeters, touches this line, so that's from here to here on the shape. This is just extended out further. I don't know why they're not dotted. They should have dotted. And this one, we don't know. Okay? Do we want a diagonal usually, though? No, we probably just don't need it. Okay, so let's go ahead then and figure out how could we use it. If that was, we could do that rectangle just fine because it's 16 by 36, right? But like she said, we got to take out the white thingy. Yeah. We could also do this, right? And then it would just be half of that rectangle. But what do we do with this measurement here? What are your thoughts?
There's a little tiny triangle to do that on the other side.
You're right, there is. Oh, a teeny tiny triangle. Do I have to pay attention to that? Is that okay?
Maybe.
I have to pay attention. What math practice is that?
4, 9,
6. Thank you, those of you that looked over there to double check instead of just randomly staring off in La La Land. Okay, so we have 6. Attending to precision, we do have to be really careful because that would be great except for, yeah, it isn't exactly half. So that's not going to work either. Good catch. Okay. So let's go back to this original thought here because there is a way to do it. Let's see. How would we take out those two amounts? Go ahead and sort of put those dotted lines down on yours lightly in case we change our mind. And then discuss with each other, how are you going to get enough information to take this out? We have this one, we would need this one. We have this one, we would need this one. How do we figure out those amounts? Are there any measurements you can put next to each other? If you had patty paper, you would be able to measure them, put them next to each other, so you can find out other measurements. Two of them? What two measurements would you like to put next to each other? The bottom and the 12. So the 20 and the 12, the measurement. The 20 and the 12, and that would leave what left over? 20 minus 12 is, so we could get a measurement for 8. So let's try that. And I'll have to do it on here because you guys have sketches, so yours are not going to be exactly the same size, right? So you'll just have to kind of sketch an idea for yourself, but we can try it here. Let's see here. Actually, let's try and be a little more accurate with a nice line. Let's give it a color line. Let's be orange. It's almost Halloween. Be a little thinner too. Okay. Think it's 4. Let's get this 12. Okay, sure. And then 20. And then put them next to each other.
Well, maybe it's 6.
Let's make sure I don't accidentally change this side. Oh my gosh, dude.
I think it's 6.
You think it's 6?
Yeah.
Okay, so if this is 12, that's still not very straight. If that's 12 and the other one is 20, look how straight. That from that height up is 8, correct? Does that look like it might be this side? Yeah. Okay. All right, let's check. Let's do a different color. Green, black. No, blue. Oh my gosh, so much to choose from. Okay. You know, but then the black is going to be mixed in. I don't know what to do, you know. I should do so many things.
It's blue.
I don't know what's going on.
8.
You.
I
I don't know. Doing stuff.
It's a blue line on a blue line.
I know my mistakes.
Okay.
Ooh, is it 8?
Yeah.
Woo! Oh my gosh, that was a lot of finagling. Okay, so that's 8. If this is 8, this, oh, I'm line. I'm gonna draw, baby. There we go. Do you think the other one's 8?
Yeah, possibly.
Right there? Possibly? Like, should we just, actually check? That's probably cool. What the what? It is 8. Oh, now we have enough information. We do. Will you please talk about, on your notes, will you tell yourself how you did this? You got the 20 that you were given, you got the 12 you were given, you line them up, and you will now get to know what 8 looks like, because that would be the extra amount above that 12. Okay, so I want you guys to calculate with the people next to you. Go ahead and calculate that rectangle that we were going to create on the side. And then let's just worry about this right side first, right here. And then subtract out those 2 triangles, see what you have left. I'm going to go fill up my water. When I come back, I'm going to be so excited because there are people over here next to the door and I'm going to be yelling. Okay. So excited. What is happening? Very exciting.
Who's the one that's always yelling?
I get to you.
Well, not too okay, then you get a 60. This one is now you know how girls feel, honestly. Oh my god. You guys are using calculators?
Yes, sure are.
Oh my god. We're not supposed to be able to do it in our head. We're supposed to understand. Are you sure it's time? 432. Are you sure it's time? He wasn't actually talking.
No, I didn't hear him. Okay. No, I went to go fill my water.
That took like 0.5 seconds.
Yeah, I'm still filling up my water. That's why when you guys take forever, we were suspicious.
Well, no, let's just
I also want to walk down there because I need to make sure my daughter's around here.
Hey.
You know, when the hubby's in charge,
I don't know.
things don't always go the way they're supposed to.
Is she here?
Yeah. Oh, she's always running. Okay. So we have this total, and you guys all have for me, right? You ready? Yes. Okay. Stand up if you think you know how much is that gray area on that left on that right.
Oh, the whole air. I thought that you were doing it.
Yeah, you guys do the rectangle and then subtract out what we don't want.
Oh.
Oh, come on, people, come on.
I just did the entire thing.
Excellent. Now, give me what's left over there. Okay, nobody's standing over here, but you're all staring at me. I don't know. Did I wear the answer today? Oh, no, it's a different shirt. I don't have the answer. Don't stare at me. I know I'm popular, but write it down on paper. Figure it out. Help each other out. Let's go. Otherwise, we're going to sit in your chair all day long, so I'm not going to do it for you. You did stuff? So you want to show us how you got the answer, Diego? You take out the white triangle. You
Oh,
don't
I
want
got
that
the
part.
answer. I got the
Stand up there. Stand
Hurrah,
up.
hooray.
I have no idea.
That's how you go
Say it again, sorry. Just so I know if you're right. Okay, now class. Is this a one-step problem? No, it isn't. You need to get the area of that rectangle first, which should just take 2 seconds. And those of you not writing down anything, that is really for practice of math practice 3 because you have nothing written down for your arguments. So start writing stuff down, please. And there's a lot of you that are just staring or looking at calculators or just staring. Okay, so make sure you're writing stuff down, figuring it out. Once you get that area, you need to get the area of 2 triangles. And then you know what to subtract out, right?
Wait, I thought you meant to get the area of that entire rectangle. Just the grid.
Yeah. Yep. You gotta do the entire rectangle and then subtract it out. We don't have a formula for that funky shape that I cut off over there in gray.
So you try to find the area of the gray.
You want to find the area of the rectangle, then take out the top and the side triangles that we pretended were there. So it's just the gray. Then we still have that little triangle pointy part off to the left we need to deal with in gray, but we'll do that in a minute. Okay. Let's unconfuzzle.
Everyone.
Yeah.
Okay. We have, oh, that's cool. I chose blue and it was like, I'm going to be yellow. Okay, we have this entire piece right here, yes?
Yes.
They gave us information that I can make that a pretend rectangle. So what I'm doing is I'm composing those 2 puzzle pieces that are not actually part of the puzzle. Okay? Do I really want this section?
No.
No. Do I really want this section?
No.
No. So it's there for a second so I can make a rectangle. Then I take away the one triangle and the other triangle and I'm left with what I want, yeah? It's the same thing as cutting off those pieces you don't want. And the gray is left over. Okay. So who has the area of the rectangle?
Oh, I know how to do it. You do 36 times 16 and then you have to figure out the triangle.
I don't know. You're doing nothing on paper. I can't tell what you're doing.
Okay.
You got to finish on paper. Okay. So let's look at, let me take these 2 things off real quick. Okay. 16 by 36. You guys see it? 16 by 36. What do you do with those measurements? You multiply them. Okay, why?
Because that's the formula.
Because length times, so first I say 16 by 36, all right? Okay, why? Because length times width. Okay, why? Why is it length times width?
Because area equals.
Yes, ma'am.
Because it's a rectangle.
Because it's a rectangle. Okay, what else? Why don't I do length times length? Or width times width? Let's go, guys. If you're going to stay in honors, you need to use brains and think about things outside the box and make sure you pay attention. Here we go. We have length times width. Why is it length times width? Why is it not just length times length? I have like one whole side and then, okay, we got some. Okay, good. We got some over here. Why? We literally have done this like every day for the past 2 days. Stephanie? Now you're going to do this again. You're not going to ask me. You're not asking me. You're not going to say, is it? You're going to say, it is because. That is true. It's because of that, yeah? That's how that you get area. Area is the same thing as length times width. Area is the same thing as 16 by 36, yeah? Now we're going to have to take some extra steps because it's tiny, it's really a rectangle. It's not. Cool. else? Make sure you've got it. While she's doing that, I'm just going to show you another method. If you wanted to do 16 as 10 and 6 of them, if I did 36 10 times, right? And then 36 6 times. Does anybody know what 36 is twice? 72. So I could do 36, 36, 36, 36, 36, 36, right? Or I could do 36 times 6 and then just add it. Or I could do 72 plus 72 plus 72. Or 72 times 3, exactly. And then I just add it with, that's the 6 of them, and then I add it with the 3 times 60 of them. Okay? Okay, so what did you get, hon? 576, you guys agree?
Yeah.
Alright, 576. Excellent, but that is not the total because I don't actually want the rectangle, yeah? So that is this shape, that rectangle. Now I need to take away this top triangle. So I'm going to tell myself that triangle and then this triangle I want to get rid of, right? So here's that top triangle I want to get rid of. How do I do that?
Exploding it. And now I can do it.
Brennan, how do I do that? Triangle. How'd you get 8? How'd you get 8? Because it's the length. Why do I do 16 times 8? You made it up, you just do. You're just like,
I know.
anybody here? Aaron Lily? Because it's length times width? Very, very, very close. I need a little more accurate. Very, very, very close. Oh wait, Enoch, did you tell me the last time? Oh, you didn't. Okay, go ahead. Because that's the area. Close. 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 Go ahead. Area equals 1/2.
Length times width.
Base times width. Same thing, length times width. I just want you guys to get used to the other side. Okay, so if that's the case, the base and the height, I need 1/2 of the base and height, yeah? Okay, everybody right now that did not know that immediately, put it in your notes for your future forgetful self, because guess what? You're not remembering. So put it in there so you can look at it. Get it in there so you can look at it. Okay, I'm going to go ahead and do 1/2 of 16. And then I've got that other 8 right there, yeah? What's 8 mean?
64.
64. So I'm going to subtract 64, correct? Yeah. Okay. So I'm going to subtract 64, so I have 576. I'm going to take away the 64. Good so far?
Yeah.
You see how I'm organizing my thought process here for myself? Or putting little pictures or something? Okay? Do whatever you need to help make sense of what it is you're doing, because you're doing lots of steps. Now I got to do this little triangle right here, right? Mm-hmm. So I would normally do this right underneath, but I'll do it over here since I'm running out of room. So we have this little triangle here. And what do I do with that little triangle over there in the corner? So, Moners, I should have everybody have their hand up. You should already know what's going on here. All right, Macy, what do I do with this little triangle on the side?
You need to, oh my gosh.
I need to find out how much space is there.
Yeah.
Okay.
And then you need to,
Look at your notes. I do, but I don't know how much to subtract it. So I gotta figure out how much is filling up that section first. How do I figure that out?
how do you figure out how much area?
Oh, I like how you said area. Good, so you got the word I'm looking for. Yeah, how How much area is in that little piece? What do we do to figure that out? Yeah.
I didn't know.
Hi.
Well, you can. Well, there's 36, so that's how many.
Okay, that goes there. What else?
And then there's an 8 on the bottom.
Okay, what do I do with those? Multiply them. Okay, why?
Because that's how you find the area.
Because that's how I find the area? You sure?
Pretty sure.
So the area is the same as what? Instead of length times width, which is the same, what do we say? Oh, it's base times height, but notice she said a half of that, half of base times height. If we just did length times width, which is the same thing as base and height, you're going to be getting a rectangle, right? You got to cut it in half because it's a triangle. All right, so Macy, don't forget that half part, because otherwise it'd be like the whole rectangle. You want to cut it in half. Okay. All right, so we want to do half of that. Okay. You want to cut, I would cut 36 in half because it's a big number and make it smaller, right? Does anybody know what half 36 is?
Oh, wait, no,
18, and then we start to do times 8. Notice again, I'm only doing one multiplication problem per line. Okay, that's not just something that I think is really cute and sweet and pretty, but that's required. Okay, then we need to do 18 8. 18 8. Well, what's 10 8? 80. And then what is 8 8?
64.
All right, let's add those up.
Whoa.
Is it? Okay. Oh, did I do that right? I thought I could. Okay. 144, yeah?
Yes.
Okay, does everybody understand how I do that and why I do that? If not, let me know now.
You have to do 8 and
Oh, I have to do 8 and a half?
yeah.
But I already said 36 and cut it in half.
You have to
So I don't have to do it half again.
we have to do half of the number, which means you can do 6 times
36 times 8. Take a look at it in your calculator. Or on your 36 times 8. Yeah, it is. Yep. You just have to do half eventually. So if we already did it once, we're good to go. We already did it. You just got to take half of something. So you either take half of one of the numbers, half of the other number, or half of the total. Like what you said. Okay? So put that in your notes so that you don't forget. Anyone else that needs to know that, you just got to take half of something. So again, we can take half of the first part, half of the second part, or half of the total. All right, so we have 144, and that's what we want, right? 144 is the area, correct? That's our final answer, yes? No? Centimeters squared. Okay, ooh, I like it. That's our final answer. That is the answer to the gray part, correct? Roger?
No.
What?
You have to do 144 minus 512.
That means I keep the triangle, skinny triangle, and I get rid of everything else.
I did it wrong.
That's okay. You meant to do backwards?
Yeah.
Okay. Yeah, this is this piece right here, right? This is this amount. So I have to go ahead and now do this portion, which I'll do this corner, and I have to get the 512 I have left, and we're going to take out the 144, right?
Mm-hmm.
Okay. Oh, yeah, so that's what, 12, and this is 50. You agree?
No.
Why not?
No.
Oh,
No.
wait.
That would be.
Say it again.
You don't need to put the zero.
I don't? Why? Because it's already in that place. Let's write it a little bigger so you can see it there. Okay, can I do 2 and take 4 away?
Yeah.
Alright, so I'm going to take this away and I'm going to turn it into a 12 because I borrowed over here, right?
You borrowed from the one. So the one would turn into 0. And then you.
Oh, okay.
guys are thinking of weird rules.
Yeah, our brains is.
No,
No, we're taking the long route instead of the shorter route.
Oh, you cross out the 1 and the 0.
Yep.
That's what you need.
Oh, wait, oh.
Yeah.
It will still become 50, won't it?
Oh.
Oh, okay. And
Oh,
that's
that's
fine. That's fine.
What do you mean?
Oh my gosh.
No, because look, what's 50 plus 12? Well, I meant, really, sorry, that should be there in this place. What was the 50 right here plus a 12b, you would be lining these two back up, right? So it's really 500 plus 12. But we 500, does that make sense?
Yeah.
But I can just think of it as 50 as well. So just to give you that reminder, you can do that as a shortcut. So 12 minus 4 is 8. 50 take away 10 is? No. 50 take away 10.
Oh,
40, back up 4 more. 36. I just want you guys to see that you can look at this as an entire amount. Okay? You can look at it as an entire, and sometimes, so this one wouldn't have been too bad, but a lot of times it would have saved you lots of time. So I want you to take a look here, because what would happen if I did it the way that you guys feel I should do it? I borrow, that's a 0, this is now 12, that's 8. Oh no, I can't do it because I'm looking at only 0 and 4, right? So then I have to borrow, I turn this into a 4, I turn this into a 10. What's 10 minus 4? Uh-oh, what's 4 minus 1? 3. Oh, wait a minute, they look the same.
I cannot do it the way that you do it. That was very confusing. That one makes way more sense now because you don't have to do all the numbers. Yeah, you don't have to
Okay.
cross out.
Because, and you can do it any way you want me to. I'm just showing you other options. So basically, instead of taking away from the 1, I took away from 51 and made it 49. Or excuse me, 50, yeah. I was looked at that number for a second. And then I just took 1 away from the whole thing. So I can keep it as 50 minus 14. Okay? Well, I can cross that over. 50 minus 14. So I got to keep the 2 digits together, okay? Does that make sense? It's just a little shortcut because I know those 2 numbers can be put together. You can do it one place value at a time. So the difference is this is keeping it in 3 columns. Okay, this is keeping it in 2 columns. Does that make sense?
Yeah.
Okay. Just a little tidbit. 368. So 368 is right here. Because we took out the 64 and we took out the 144. Woo! Now, normally it wouldn't take that long because I've been having to stop and get you guys to remember certain things and we were talking about it, right? Normally it would be work, but it wouldn't take that long. Okay, question.
Why do they teach us in all of the years in younger grades to do it that way when we're never going to use it those ways again?
Use it which way?
I don't like they teach us like mark all of those, and then we get taught something different. So
Okay, do you want to know what I'm going to tell you? I'm going to tell you the very, very honest truth. 2 things. 1, a lot of adults have not even thought of it that way ever. They wouldn't even know to teach it to you that way. Because we were trained only to know one way to solve everything. I did not even know that I could do something different than this. For years and years and years, after I taught 15 years, and probably a good 7 years, I screwed up kids too. No, it's on the one way, because I had no clue. Did we ever mention it to me? Because math was not creative then. It was school math. You have one way, you memorize the rule, you better follow the rule, and that's what you do. Why do you do it one thing at a time and you borrow one next door? Because I said so, that's why. We don't really know that's what we do. So a lot of teachers have no idea to look at it differently. And another thing, besides that, is they may not be confident in teaching it a different way. Either they didn't know or they're not confident in teaching it that way. So that is why that's part of my job. My specific job is not to just teach you guys, but Ms. Proctor and I teach teachers. So we are trying to show them all of these creative ways to themselves. Because they can teach math, but that's great, just like I did for years and years and years. I taught math the way that I learned math, because I didn't know there was other ways to teach math, right? But once you start seeing creative ways of looking at the numbers and understanding, you can do with it whatever you want to make your life easier. There's lots of ways to take things apart. Then you have more options. Like this one is decomposing. This is decomposing. So that you have the hundreds, the tens, and the ones. This one, I did the tens. How many tens do I have? I have 5 tens. Isn't that 10 minus 15? Yeah. So I'm thinking of it as 5 tens and then the ones. So I'm breaking this into tens and ones instead of hundreds, tens, and ones. So we're just decomposing it different ways. So it's not that they don't want to show it to you until you get to 6th grade, and this is the 6th grade way. This is just another way, and they may not have known to show you or felt like showing you. But that is my job, is to make math a little more accessible to everybody. Okay, this section now is, what do we get our total, 368? Woo! Oh, I'm on highlighter. Now we just want that little triangle right there. Can we do that little triangle very quickly? Okay, we have 8 and 12 going down the side. Could we figure out the rest of the height for that triangle?
Yeah. Possibly, yes.
Do we have a total?
Oh, wait. You just minus it from 36.
We can. Just subtract it from 36, so you get your 36. Let's get rid of all this good stuff here. Okay. You guys, all these little lines, all the lines. You can go away now. Oh, they're locked, that's why. I think it's because they're locked. Okay. Anyway.
So they don't change size.
Yeah, so I don't. Oh, gosh. Okay, cool. Now everybody over here. Go away. So pretty. Okay, we cut this right. Oh. You laugh, you're gonna ask. Okay. We cut this part right here, 368. This portion up top was 64, but we didn't need it, so we got rid of it. That little portion on the side was 144. We got rid of that, right? Go ahead and put that in your notes as well. Sup, bro. Sup, dog. Soy dog. Yeah.
It sounds like soy dog.
Yeah.
Soy dog. I love soy dogs.
Because kids these days, it's hard to enunciate syllables. Soy dog.
I like
soda.
soda. Yeah, I like soda.
You know what I'm saying? Yeah.
Everybody always says, oh.
You guys, we're getting older. We should be like years and years of technology, yet we are talking like cavemen. See, we think that they were just not sophisticated. They were extra sophisticated, and they were like, we are so amazing. We don't have to say our whole words. We just make grunt noises, and people they're like totally getting it. You're like, how is your day, fellow sir? Yeah. Look how much more convenient that is. Okay, anyways, weird people. We have 8. We have 12. We can just take that away from 36, and we would be left with what? What's 8 and 12, everybody?
It'll be 16.
What's 8 and 12? 20. Take 20 from 36.
16.
Excellent. 16. Those of you that are not doing anything. Suck it up, buttercup. Do it. Okay, if this is 20 from here to here, I don't want that. I just want from here to here. How do I figure that out? How do you know it's half?
20 minus 16. That's the top right there. 16. But it's not the exact right.
Okay. So 20 minus 16. So that's 16. That is 16, yes? But we want this one. But is this 20 all the way across? See how that would, that is true, 16 and 16. But how do we know this? We know this is 8. We know that's 8. So if this whole thing has to be 16, and we know that part's 8, what is this part? 8. So now could we do 20 minus 8?
Oh yeah.
Well, 20 minus 8.
Wow.
So what does this have to be?
Whoa.
12. We could also measure this one right here from there to there and see if it matches from here to here, yeah? Ooh. Okay, so we're going to reverse that. We're going to go over that again, I should say, not reverse it. Rewind. Make sure you have that in your notes. That is a lot of sophisticated thinking and really understanding the situation and what you're given. So again, we have this measurement that is 12, and then you have a dotted line. From here to, wait, was it all the way dotted? No, it's 20, right? Sorry, 20. Okay, and then it goes up, and we have 36, and this is 16. Okay, so 16 and 16, right? If that's 16, that's 16, correct? Okay, and if this entire thing right here is 20, and then from here to here, if this we know was 8, this has to be 8, because 8 plus 8 is 16, correct? Okay, so if we have 8 out of 20, then we just need to say what plus 8 is going to equal to 20, and it would be 12. Okay, so that's one way to kind of get all of those measurements. This measurement over here on the side is because we took away the 8 that we figured out, plus the 12 that they told us, and then we just took that away from the 36 so we can figure out what would be left over, 16 more. Okay, so I want you to really think about how are you going to make that note so that you can show yourself how to get things that you're given and take away certain amounts so that you can be left with what you want. If you're watching me erase, then I'm going to ask that you look at your notes. Feel your eyes. Oh, I don't need to write this down. I totally will remember this forever and forever, even though I daydream the same part of time.
Exactly.
And then I'm going to be like, what is it you're remembering forever and forever? You already know how to do it. You're going to be like, The answer is Tuesday. No, wait, Wednesday. Yes. Absolutely. Stephanie, get out of here. Push your chair in first. I know you that. Okay. Now, do we have enough information to get that little triangle there? Do we have a base and a height?
Yeah.
What's this amount? 16. What was this amount?
12.
12. So 16 and 12, and then what do we do when we're done with that? We multiply them, and then we divide it by 2. So I can get a triangle. This is a triangle. Exactly. Yes. Amen. And then we're gonna add it with the 368. Okay. Now that we know all of these lovely little tricks we can do, okay, we're gonna take a second here. Because if you look at that and you're like, oh my golly gosh, there's arrows and numbers. You're gonna die in life because that is not complicated. You just need to chill out, take a look at it, and don't get a driver's license because the moment you're like, there are cars and roads and signs, you're gonna be on the road with me, and I'm terrified of you. So relax, take one thing at a time, filter. Let's just see what we have given. Take it apart and draw it separately if you need to, okay? So on your notes, let's uncomplicate this. So I would sketch something very similar. That's what I would start with, okay? Something large enough that I could write some numbers inside once I start getting some totals. Now we want the shaded region, so we want to get the grays. We're going to have to subtract out the star, yes? You guys see that?
Yes.
Okay. We got to subtract out the star. So if you need to, here are just some tips, some things that you can keep you organized. If you need to, get a highlighter and highlight the region that you want. If you want to remember, or vice versa, you highlight what you want to take out, whatever makes more sense to you, so that you can kind of keep it straight. Besides, once I do this, things kind of tend to pop out a little bit more once I color code them. I'll give you some examples of how I could use this information that would be very helpful. Let's say I shaded it this way. Okay, I can clearly see but I don't want the star, correct? Okay, what's the outside shape? A square. How do you know it's not a rectangle?
It's all
Well,
sides.
it is a
All
rectangle,
sides
but
are
it's a special kind of.
Yeah.
Whoa, brownie points. It is a rectangle. It's just a very special one called a square. And how do we know it gets its special name? Yes. All the sides are, congruent. Even use a big kid word, not equal. Wow, brownie points all around. Brownie points all around. Except for, sorry, I'm going to eat them all first. So, the brownie points are delicious. And because it's a square, I can get the entire area and then take out the star, correct? Okay, so we're going to use the star formula, right, that we have?
Star formula.
We
don't
totally
have a star formula.
Oh, that's right, we don't. So we are going to have to do something different.
Right.
Okay, so we need to,
They can do the star.
no, not, you can cry while you work, that's fine, just keep it down. It's awkward to hear weeping in the corner. We can cut this star into some other shapes that we know. How can we decompose the star into shapes we know? We've got squares, rectangles, parallelograms, and triangles. Those are the 4 options. Good, I see some people and the same over there on that side. We've got 4 people on this side, 5 people on this whole side of the classroom that need to speak up a bit more. I haven't seen too much from. This side, I've got a little couple up here towards the middle-ish area that needs to raise your hand. Yeah. Who? No, you're fine. You just gave me some information. Tell me, right? Okay, I want you to go ahead and sort of decompose. Don't put any numbers anywhere yet. So if you have, just stop doing that for a second. Just decompose and show yourself the different sections. Highlight the different pieces if you need to. Well, good thing there's a whole bunch inside. I'm going to highlight so that all of the same congruent sections are the same color, okay? Because I am looking, and because this is a square, I know that this guy is the same as this guy. And this guy. And this guy. You think so? That's what you think it is? Okay. And then I got, I'll make it pink.
They don't look like they're the same. They look very bad.
I know.
And then that's when you write a little note and be like, shut up. Because you're talking to yourself, right? Shut up. This is great. It's perfect. Don't judge. Don't judge me, myself, and I.
Oh,
Yes.
because it says that there.
Oh, excellent. Cameron's feeling pretty confident. Cameron, guide us. What do I do?
also confusing because that thing.
Hold on, Louie.
You can take all the.
You know what? I'm so glad you said that because I love new ideas I don't think of. Yes, I could go ahead and take all of these triangles off
So we just make this square.
and make a little rectangle. Find the area of the rectangle and then at least all the yellow part up here is gone, right?
Yeah.
Ooh, very nice. Let's say that I were to do that as a rectangle. So if I had this would be really convenient with patty paper, right?
Yes.
Okay, this would be a patty paper moment. Okay, we have one here, and there, and then there. Oh, we'll pretend that's totally equal. Totally equal. Look how pretty and equal that is. Okay, so if that's the case, let's see if we could do that. Let's get some measurements. So you would need to take that off and figure out how to rearrange it, right?
Yeah.
Okay, so here's option 1. Let's go ahead and put down some measurements there. What is the measurement from here to here? Oh, that didn't change. Hold on. From here to here. 20? Okay, so what would 2 20s be?
40.
So this is 40, and then now this is slanted, so do we want to just go straight down? Is it a rectangle or is it a parallelogram? Okay. Well, it's not, but you can make it. Okay. Does that make sense why it would be a parallelogram? Okay, so they're just slanted on both sides. So what's the height here? I heard it. What is it? Look at it right here. It's pointing to the dotted line.
40.
40, right here. 80 is this side. 40, see the arrows pointing to it? Okay. So 40 and 40. So we have 40 by 40 is?
80.
It's adding.
800.
No.
Oh,
100. Oh yeah, 100. 160.
160, yeah. 160. Okay, or, right, 160? Ah, 1,600. Because we have 16 and then those two zeros. Okay, so 1,600 is going to be now this is yards. This is a large area. That's 80 yardsticks across. Okay, and a yardstick is 3 feet, 3 rulers worth about this high. You can see a yardstick up here, well, a yard, excuse me, from that line all the way over. It's 80 of those top lines, all the way across. So this is going to be a lot. So we are taking out a whole bunch here. We're taking out 1,600.
That's like the size of.
So we're going to do first, let's do the square. So I would draw a square, so I know that this is for my square. And I would say, just to keep myself straight. All right, and then we have, the side is 80, yeah? Oops. So what's 80 times 80? Or, put your 2 zeros down. What's 8 times 8? Yep?
64.
Is that a cursive S?
It is. Where the cursive S is.
I know.
Oh my gosh, you guys really need to. Yes.
We've never learned.
Well, then you do something about it. Yes.
Yeah, I could.
I'm so sorry, you guys. Hey. Yes.
I don't remember how to find the area of the triangle. Just circle out the area of one triangle and times it by 4.
Love it. Okay, let's do one triangle. Okay, one triangle we had 40 by 20. Yes?
Yeah.
Okay, let's do one of these. Okay. Half of 40. Oh, good. Oh, good. Okay, good. 40 and 20. Okay, what is half of 40?
20.
20. So what is half of, or excuse me, what's 20 by 20?
40. 400.
400. Excellent. So 400. And then I'm going to do, if one of them's 400, I'm going to do that 4 times. Yes? Take away 400, another 400, that's 800, 1,200, 1,600. So we now know how much to take away, yeah? Okay? So we're going to get our total, the 6,400 for the square, right here, and we're going to take away the triangle. And I might want to put over here like a little note so I remember, why am I subtracting that? So I'm going to go ahead and take away all of the triangles. Okay? Oh, wait, keep going down one. Where's my pen? How rude. Okay. Anywho, and then we have, what, 64 take away 10.
54.
54 take away 6 more. 54 take away 6 more. 54 take away, good, 50 and then 48. 4,800, am I all done?
Is it
No.
each
No.
Is it each yellow triangle? Is it that each 1,600?
No, that was 4 of them put together right here. Because Cameron said we can put them together to create, we've got the parallelogram, so that was doing it all 4 at once. One triangle would be,
Wait, but then why is each yellow triangle 400 instead of 40?
no, it's 400. The measurement on the height is 40, and then the base is 20. No, you're adding. You're going to multiply. That would be 800. So you're adding 60. You have to multiply. You're doing 40 plus 20, right? No, 800. Let me go over here.
It's not 40 times 2, it's 40 times 2.
So 40, 20 times, right?
Yeah.
Okay. So 40, 20 times. What's 40, 10 times? Okay, what's 40, the other 10 times? Should be the same. 40, 10 times is?
400.
So 40, 10 times is still? Okay. So here's another way to think about it. So 40, 20 times is 800. Or you could just take off these two extra little zeros, because it always has this pattern. Just put them in the answer, and you have 4 times 2. But that is length times the space times height, right? For the triangle.
Oh, so
We
each
got it.
parallel is 800.
Well, we got to cut it in half because it's a triangle. So we take, so each, if we cut it in half, then it's going to be 400.
I get what you're saying.
Does that help?
Yeah.
Okay. So this is one triangle. Yeah. So we put 400 around, and 400 4 times would be 1,600 total. And then so what we did in the red down there with all the triangles is Cameron just said put all the triangles together, and then it would just total immediately 1,600. Or Lula said you could just do one triangle, which is 400, and then just repeat that 4 times, right? 4 exact triangles. Okay, good question. Anybody else not sure what's happening so far? We're good? Okay. Did we subtract everything we wanted to? We didn't do the square in the middle, yes. So we've got rid of all these. But we need to do the square in the middle. Okay, what do you think? Uh-huh. Yeah, what do you think we should do? What do you want to do with that square? Area equals. Okay, so area equals, we could do length times width, we could do base times height. We don't actually have to be so specific though because all sides are the same. So what's the other version we can do for a square? Say it again, Chris. No, we got that one. We got that one. It's the same thing, base and height, or length and width. Or what else do we call it? Lucas?
Base times width, right?
No.
I remember.
Kimber? Side squared. Side times side, which is side squared. Side times side, which is really side to the second power. That's the one we generally use for squares. If you see that, because we don't have to be specific, which one's the base, which one's the height. Which one's the length, which one's the width. We can just pick any of the two sides and we're good. If we're not careful, somebody might look at a rectangle and do this one times this one, top and bottom, right? Is that okay? So just pick any two? What if they pick two and it happens to be the two sides? This way. Is that okay most times? No, so we have to be really specific to show them it has to be one direction and another direction. So whatever way you think is the length, take one of those, and whatever way you think was the width, take one of those and you multiply them together. On a triangle or a parallelogram, you need to get the base, which is one direction, and the height, which is the other direction. Those automatically, base and height, always have to be opposite of each other because they have to make a 90-degree angle, correct? So if you say base and height, there's no confusion. You're definitely going to take those two different directions. On a square, you can just pick two of the sides because they're all the same. I don't have to be careful. I can take these two sides because it just happens to be the same numbers multiplied together, right? This is the same as doing this on a square, isn't it? Yeah. These two numbers are the same as these two numbers, correct? Yeah. So that's why we're not really specific. We could just say, just get the side and times it by itself, which is side square. So make sure that you understand that because this is the formula you'll see for a square. Even though these two work as well, I still want you to know what that means, okay? So then, Decker, what number would I put in side squared? 20 times 20. Okay, so I'm just going to write it over here because I'm running out of room. So it would be filled in 20 to the second power, which is 20 times 20. I'm going to have two of these zeros and two of the twos. What's two twos? 4. All right, so this little guy inside is also 400. Ooh, interesting. It actually has the same space as a triangle. You just can't tell. The triangle's a triangle. So it basically decomposed itself into some pieces and just like squished it, right? Same space, just squished. So now we would subtract another 400 out. When we subtract the 400, guess what we're left with? The blue. Zero. Zero. Gotta start all over. We got nothing. We took it all away. How much carpet is in here? Well, we're going to take this. We're going to subtract from that. Subtract from everything else. There is zero carpet. No carpet.
This is just hard.
Yeah. How much carpet do you need to buy? Oh, nothing. Nothing. I'm good. I'm good with some concrete.
Don't fall. Because there's nothing underneath.
Actually, let's do this. Concentrate. Hey, sketch this one here. Again, don't start freaking out. I would let you guys move on, except for I can already tell that we still need practice on it, and that's okay. You don't like it? That is so weird because it was like, you know what, I said they made all this morning, but you know that Charlie? I don't like her, and I was like, it is okay to shape, just shape so you make it. Then we're not working with it. Let me tell you something. The shape. You're complaining about it. It was weird. It was complaining about you. It's 22.
Oh, wow.
I told that shape, I was like, chill out, shape. Shape, you sweet turtle. It's gonna be okay. Yeah. Okay. That is not a parallelogram, no. But do you see a parallelogram in there somewhere?
Yeah.
Oh.
Yeah.
Oh, yeah.
Even this one, like, what is that?
Right here.
I do. I love it. Yeah. I mean, it's all right. You may not, but if somebody asks you to build something for that snake, you know, so it doesn't breed too many people. You'll be able to build something for it. I wasn't measuring things.
You were measuring how many people
Brennan.
he breathed.
Just to help us with stuff for the future, why do we have to figure out every shape like this?
No, you got
Because it is called real life, and good luck finding beautiful, perfect shapes in real life.
Yeah.
Yeah.
Like that poster.
There's only a few million.
Yeah, except in real life, people are.
Have you ever seen plans? Have you ever seen plans of something that you're building? Have you ever seen the shape of a yard or a plot of land where you put your house and your land on? Almost always, they are not exact at all. They are funky shapes.
It's just like how to find an area. I'm not planning on making
Well, here's the thing, class. Let me show you something here. Because I don't like whining. And I'm hearing a lot of it. Okay, I'm so sorry. Voices are off. It's my turn. I'm popular. Be quiet. It's me. It's all about me. Okay. We are going to look at, let's see if I can find it here. I'm going to show you what my land looks like.
Are you gonna go on like
Shh. Quiet, please. Thank you. Let me see where my plot is. Oh, maybe it's this one. Yeah, this is the house plans right here. Okay, now here's the thing. You guys, listen. Before you whine and complain, but these are really good questions.
But we really like whining and complaining.
Yeah, I know. And I love it so much.
Our favorite activity.
I hate whining and complaining. It's the worst.
You can't whine and complain until you try it.
I like
Yeah.
I was a kid. I've tried it.
Whining and complaining is awesome.
Now,
What is
okay, listen. Quiet. Shut up. Gee, shut up.
That's a bad word.
Where is this?
That's my house.
No, like where?
Where? Right there. in Sanskrit. Give me 5, 4, 3, 2, 1. I like to hear my voice. You guys all stop. Okay. I am not an architect. I do not build houses. I do not own a landscaping company. I do own a home. I'm an average person who owns a home. Guess what? They do not come out all beautiful. This is the shape of my lot. It is right here on a curve because I'm on a cul-de-sac. So it starts out not even in a straight line. It goes straight back to another corner, and then back to the curve. Because it is a funky shape, because it is at the curve, it's like the top almost of a cul-de-sac. So this is a real life version of what I have to deal with. Okay? Now the dark gray part, the dark gray, is the actual outline of the house. The shaded lighter gray right here with the thicker, that's all the cement. And this portion right here is where they put down, it's like a gravel base underneath the driveway. So that's it's just showing the different materials laid on top of itself. And there are all these extra details and stuff. But notice, you guys, there are funky shapes all over the place. Even this, look how nice and squared and boxed and everything it is, right? Do we have the ability to decompose that into some rectangles?
No.
Yeah, that's what they do to get flooring. That's what they do to get flooring. Here is a floor plan here. Notice that they had to actually cut it into sections of rectangles and different pieces. But look, this is my downstairs game room. It goes like this, and then it goes out, but then it goes in a little bit because we have stairs. My kids have like a little under the stairs house. This is not all one rectangle. It would still have to be decomposed into sections because I have carpet there. Okay? I have walls that block in certain places. I have bathrooms that are in here that we need to cut out. Look at my top floor. Let's see here. Okay. This is open to downstairs, so this is the top floor right here, like this. Okay? We have a bedroom here. We have a bedroom here. If I were to look at this and actually trace it for you, let me show you really quick. Let me get a blank paper so I can do this. Okay, I'm going to trace you guys wrong button. I'm going to trace you guys the outline of the upstairs before you get into the doors. Excuse me, the bedroom. Yeah. No. Okay, look at that shape right there.
It looks like half a t-shirt.
Okay. This, B5. This right here. Okay. This section right here is, this goes into a playroom that's off to the side. This little part right here goes down to stairs. This little side is a balcony. This way goes into a bathroom. This little corner goes into my daughter's room. This goes into my son's room. And this is part of the closet inside of his room. Okay, this is just a wall here. There's a window, and this has a bench right here. And that is just not even in a room. That's just in between rooms. Notice that in real life we do not have real shapes. Yeah, they're not all beautiful and perfect. Even if they can make the bedrooms look fairly rectangular. Okay, so just so you know, that is why we have funky shapes. So very good questions, but yeah, that's why. Okay, landscaping, I have to pay for curbing, or to pay for my deck, or to pay for a certain amount of dirt that goes into places in the backyard, or to pay for a certain amount of grass that is not in rectangular sections. So you've got to know how to do these things, whether it's your job or not. You will most likely, if you're a successful adult, come across situations every now and then where you are going to have to know this. So this is where you get your background knowledge, right? So then when you don't have your 6th grade notes, but you have Google, you do a really quick recap of what the formulas are, and you're like, okay, I do remember that, because I've used it, not just in 6th grade. You're going to use these, you'll be doing geometry until you graduate. Okay? So you've been doing it since 3rd grade. You've been doing geometry. Okay? And so you'll be able to use all of that background information with a little quick reminder, maybe you need it, and then you'll be able to figure it out yourself. Okay? So, don't bash on it. Take it seriously. I don't waste your time, I promise. I will not waste your time. Because my rule is 90 minutes of math, yes? And I don't like school math. I don't like math that's pointless and boring. I'm going to make sure you have stuff that you're really going to need. So, you gotta trust me on it. Okay, before we have to leave, let's take a look at this one. We can definitely see, or I hope that you can see it. Oh, I shouldn't use blue. Alright. I hope you can see this little parallelogram right here. Can you guys kind of see that?
Yeah, you can make it.
Okay. Yeah. Now, one thing is, you could get the area of a trapezoid, and I could show you how to do that. I will for the honors class if we have time, but for now, could I repeat this? Possibly. This is what I'm wondering. I'm going to have to flip it too. I'm wondering if it will. This is like, it's off my touch screen. Oh, I was wondering if that was going to make a square. It's a little too much inside. Darn, I made a rectangle. I was hoping that we could copy it and make it a rectangle. Could we make something smaller though? Yes, that might be a little difficult to figure out those measurements, but I could.
No, I already
Think you got it?
solved the entire thing.
Oh, excellent. Okay. Did you break it into a rectangle down here?
Yeah, no, I didn't actually do that. I took the top part and
Okay.
I broke that in half. I took a 7 and a 2, and I found the measurement for the 5. And so I
Oh,
realized.
so you took these two lengths right here, and then you were able to get a length that equals 5.
Yeah, and that
Okay.
was the wall, not the full wall, but the wall for just the rectangle. And so I solved the rectangle, and then I found out that
Do you
the
mean
size-
this rectangle right here?
no, the blue one, or
Oh.
yeah,
Okay, okay. So
So
you
then-
solved for up here.
yes, I
Okay.
solved that, and then I went down to the bottom thing.
Was this 5?
That yes, that was fine.
Okay. Oh, and you've got 7 plus 2 more right here, right?
Yes.
Okay,
So then
gotcha.
I realized that the angled ones were 2.
These?
So, yes, those were 2.
How did you know that though?
I used the same piece of paper, and I just have patty paper, and I put it
Okay.
right against it, and I
Okay.
found that.
Okay.
And so then I cut the wall in half. I cut the shape in half.
This one down here?
Yeah, this not
Straight
wall.
down in half?
Straight down.
Okay.
And then I
Is
realized,
one side the same as the other though?
yes. I think so.
I'm confused.
Well, he's just sharing his idea of how he decomposed that. You're welcome.
But also you said yeah, and then I figured out that all the bottom, the side, and the top were 2, so I just cut the top in half. So if it's cut in half, that's 7, and I got 2 on the right side. So then I did the right side, and I didn't get to the left side. But it's 2 by 2 by 1 did the math, and that's 4 by 35, which makes 39, and then the left side is on the last part.
We'll have to see if that works. I like how you're decomposing it and you're rearranging into different shapes, so let's see if that works, okay? Go ahead, Isabel.
You can take the wing triangle that is kind of partially cut off, and you can put it on the other side and make it rectangle.
This one right here?
Yeah.
So you want to put it over here and make a rectangle?
Yeah.
So then it's really 7 by 5?
Yeah.
Okay, well let's just get that right now. What is it, 7 by 5 is?
35.
Alright, so this portion up here is 35. Yeah? Okay, yeah?
The little thing I just came up with, it's not for the entire area, but like to find out that little pocket on the right.
This guy right here?
No, that was the one I already solved.
Okay, but hold on. That was really good. Hold on. So this one is for this part or this part? Right? Oh, okay. Ooh. Okay. Let's see. What do you guys think? How are we gonna get that bottom section?
Oh, yeah, down 2 times down.
Let's see. Let's get some measurements here, as many as we can get right here. So we're going to get rid of the top, because we already know what the top is. So let me put a little thing over here and make that go away for a second so we can see. So let's cover this up. Okay. Okay, so this is what we have right now, right? We good so far? Okay. We know that, and if this is really hard for you to comprehend, like you have no idea how we're doing this, you should be writing even more notes than anyone else. Yeah? Showing yourself good worked out examples, telling yourself what we've been talking about in class, so that you can do this on your own by looking at your example and be like, okay, that's what we did on this one. I'm going to use this information for my situation, and then now I can do this on my own. So if you are not quite sure, the worst thing you can do is just sit there and stare like this and do nothing, which I see about 5 people doing. I'm kind of disappointed. I'm hoping that I haven't heard anything from them. That looks like 2 or 7. So I'm hoping that they're going to be able to help us out. So that was 7. If this is 2 and this is 2, so if we can figure out this portion and we can figure out this portion, we know it totals 2. We know they're not the exact same. This one does look similar to this one, though, doesn't it?
Yeah.
All right, so I'm going to measure that real quick. All right, and oh, nice. Okay, good. So that's what you were saying. Okay, so if that really is 2, then now we can figure out what the rest of it is. If that's, why does it always get that? Okay, if that's 2 and that's 2, what does this have to be so it can equal 7? Everybody? 4. 3, 4. 3.
And check it.
Thank you for proving that to me. I agree. Now I'm going to write the other one. Okay, 3 plus 2 is 5, 2 more is 7, or 2 and 2 is 4, plus 3 is 7. So that is going to be 2, 2, 3. Oh, guess what? If this is 2, this is 2, yeah?
Yeah.
Oh. So let's make this a big rectangle. Take out those 2 triangles. We're good to go. You guys agree? Now notice that this triangle is not the same as this triangle. One's a little bit longer. If you were to actually do it, the real measurements, I know you can't on your sketch, but if you were to do real measurements, flip it over, you would notice that we would be able to do it. So, because we have lack of time, let's go ahead and just write down really quick what you would do. You would do a rectangle that is 2 by 7, and then you would subtract out the triangle, which is 2 by 3, and then you would also subtract this triangle, which is 2 by 2. And you'd be left with the gray, correct? And then you put that total with the 35 up the top, up above. Okay, with the whatever that is up above, and you get all of the gray. Okay, awesome.
Wait, how are they both 2 by 3? So one of them is 2 by 3.
Yeah, one's 2 by 2, one's 2 by 3.
Oh,
Okay, if you have a job, make sure you read it very carefully. You do everything. If you do not have a job, your job is to clean up your area. And if you want to be nice and erase something, that would just make it faster. Say it again. Yeah, you can totally get a point up there. That's fine.
does that mean we win?
You did win me. I don't know if that's how we say it, but sure. You win me. Congratulations. You gotta feed me and bathe me and sometimes take me for a walk in nice weather.
Yep.
You're not a dog. I didn't have a dog. Yes.
I have work I need to do in Collins and Garcia, so that's what I'm going to do.
That sounds fine.